welcome to True Projects. In this video, we are going to explain about the project that is a two-level ensemble learning framework for enhancing network intrusion detection. Before getting into the execution, first let us understand what is the project about. Intrusion detection systems, that are IDS. They are like security guards for your computer networks, and it is designed to monitor network traffic and spot any unusual or unauthorized activity that could indicate a cyber attack or a breach. Think of it as a watchdog that is constantly looking out for signs or trouble, whether it is someone trying to access sensitive data or install malicious software or disrupt network's functionality. And there are two main types of IDS: network based and host based. A network based IDS monitors all the traffic coming in and out of the network, while host based IDS focuses on single computer or server looking for suspicious actions that might indicate a problem. And IDS systems, they generally work by using a set of rules or patterns that describe normal behavior. If something falls outside of those patterns, it triggers an alert. But here the thing is, as cyber attacks evolve, these systems need to adapt. That's why we are seeing more advanced ideas that uses artificial intelligence like machine learning to detect threats. These newer systems can learn from data and make smarter decisions, which makes them better at spotting even subtle signs of an attack. However, AI powered IDS systems are much better. They still face challenges like producing too many false alarms or missing some real threats. That's why improvising IDS is an ongoing process, making sure that they are fast, accurate, and reliable enough to protect networks from increasingly sophisticated attacks. Even though IDS has improved over the years, many existing systems that we still have, they haven't been tested extensively across various datasets or types. This limits their ability to adapt to different environments and handle the complexity of real world scenarios. A system that works well in one situation may struggle in another, and the variety of cyber attacks happening today only makes this problem more pronounced. The key issue here is that these systems aren't always versatile enough to detect all kinds of threats reliably, especially as new attack methods emerge. And the real challenge lies in combining the strengths of multiple detection models to improve the accuracy while reducing false positives. Some models excel at detecting specific type of attacks but may not handle others as well. Or they might trigger unnecessary alerts that overwhelm security teams. The goal here is to create a more robust system that uses the best features of different models to make detection smarter and more reliable. This is especially crucial as cyber attacks evolve and we need idea system that can scale and adapt to handle emerging threats effectively. So the system that we are proposing aims to improve network intrusion detection by using different ensemble learning techniques. So here we will be leveraging specific ensemble learning methods to detect the intrusions. First, we start by picking up the most important features using the technique called information gain. So this step helps us to clean up the data by removing irrelevant or less important information so that we can only focus on the key factors that actually help in detecting threats. By doing this, we make the training process more efficient and we have also improved the accuracy of the model because they're not getting distracted by the unnecessary details. Once we have refined the data, then we use machine learning models, different ensemble models that are decision trees, Random Forest, XGBoost, Light GBM, ADA Boost, and CAD Boost. Each of these models brings a different strength to the table, and by using them together, we can enhance overall performance of the system. These algorithms work together to learn from the data and make better predictions, which ultimately helps in detecting intrusions more accurately. And we evaluate the system using three different data sets to make sure that it works well with the different scenarios. So first we load the data. That means we take the data of SIMARGI 2021. So this is collected from live network traffic as part of project in the European Union. So this contains the network traffic of the European Union. So this data set gives us real world traffic patterns so we can test how the system performs on the actual data. Then the next data set is NSL-KDD. So this NSL-KDD is well-known benchmark in intrusion detection. It has labeled instances of normal and attack traffic, helping us to test the system's ability to distinguish between the two. And then we have considered the other data set, that is CIC IDS 2017. It is specifically designed to simulate real-world cyber attacks, making it another great resource for evaluating how the system can handle a variety of attack profiles. So all these three data sets are taken from the Kaggle repository. So these three data sets are taken from the Kaggle repository, which is an open source for the data sets. So all these three data sets, that is SMI, SIMARGL, NSLKDD, and CIC IDS 2017, are being taken from the Kaggle repository. It's a platform that provides a lot of public data sets for research and development. To assess how well the system is performing, we have used evaluation metrics that are accuracy, precision, recall, FN score. So we have used these metrics to evaluate. This helps us to get a clear picture of the system's effectiveness and ensure that it can reliably detect intrusions. So by bringing together different models and focusing on selecting the most relevant ones, so the goal is to improve the overall accuracy and trustworthiness of the detection systems. So this is the proposed system of the project. And moving on to the extension, to further improve the accuracy, we have incorporated some more ensemble models that are boosted decision tree and extra tree. These models combine predictions of multiple models, which helps to make the final prediction more accurate and reliable. Think of it like gathering opinions from different experts, bring out the best of each individual model. So here we reduce the chances of making mistake by considering the multiple viewpoints. On top of that, we have developed front end using Flask framework. So this allows users to interact with the system easily. They can input network data and get predictions from the system. We have also included user authentication mechanism. So we have also included user authentication mechanism. So only authorized users can access the system, ensuring that everyone's interactions are secure. The front end gives the system a more user-friendly experience while also making sure that it stays safe and secure from unauthorized access. The goal with this extension is to make the system more functional and improve its overall sustainability. And moving on to the implementation, to implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the necessary libraries such as pandas, numpy, matplotlib, scikit-learn, and flask that will help us with data processing, modeling, visualization, and building the front end. Then comes exploratory data analysis part. So here, all the three data sets which are SIMARGL, NSLKDD, CICIDS, all the three data sets are loaded, which contains network traffic data with the labels indicating whether traffic is normal or an attack. And here we understand the data set, structure, patterns, because we need to know how we have to work with the data set. Then comes data processing. So here we clean the data by removing duplicate entries and fix missing values. We also apply normalization to ensure that all features are on similar scale, which helps to improve the performance of machine learning models. Then comes data visualization. So here we visualize the data using graphs and charts to identify patterns, correlations, and outliers on the data. This step helps in better understanding the dataset and preparing for feature selection and model building. Label encoding. Since the data contains categorical variables, that will be converted into numerical form. This makes it easier for machine learning models to process. Feature selection. So here we select the most important features using information gain. So this reduces the dimensionality of the data and ensures that only important features are used, which improves model accuracy and reduces overfitting. Splitting the data set into train and test. Here we divide the data into training and validation sets. The training set is used to train the model and validation set is used to evaluate the model performance on unseen data. Then we initiate all the machine learning ensemble models and that will be trained on the training set of the data, allowing the models to learn patterns and relationships between the input features and the target. Then we evaluate all these models using accuracy, precision, recall, and FN score. We will compare them through the graphs. And coming to the part of front end, the front end of the system is built using Flask, a Python web framework. It includes registration and login system, which allows users to securely interact with the system. And user data is stored in the SQLite database. And in the front end, users they will be able to give the input feature values that will be pre-processed at the back end. It will be fed with the trained model. Finally, outcome will be displayed through the front end of the application, whether there is attack or not. And these are the algorithms which are used to detect the intrusion, network intrusion. So these are the models. So this is the extension model. And coming to the requirements, to implement this project, we need basic requirements which are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 20 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, and backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, we are supposed to open the code folder that contains source code file. So let's open the code folder. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in this folder and this folder, we have the raw data set that is used in the project. So let's open this one. So this is the raw data set of CIC IDs 2017. And here in this folder, we have raw data set of NSLKDD, and here we have of SMI, SIMA, RGL. So the data set which is in these three folders will be pre-processed. After pre-processing, here we have that data set. So here in the CIC process, we have this data set. So that is pre-processed here. It's being loaded, just wait for a while. So here is the pre-processed data set. Initially we had raw data set, right? So that after pre-processing, this is the data set, how it looks like. And on this data set only, we will be training the models. Similarly, we have NSLKDD. So this is the NSLKDD and this is the SIMARG process data set. So this is the SIMRG process data set. And here we have the class label that we will be predicting. Close this. And here in the model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files. So here it is stored in all these three files. So these are the sample test cases that we will be using in the front end to predict the network intrusions. Let's get back. And here, this is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the static folder. In this folder, we have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And this is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have multiple notebook files. So these are the notebook files. These are the Jupyter notebook files, which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have three notebook files because in this notebook file, we will be loading the CIC IDS 2017 dataset and we will be training the models on that particular dataset only. Similarly, NSLKDD and SIMAR GL dataset. So this is why we have three notebook files. And this is the signup.db file. This file is a database file which is used to store the user information. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. It has been opened. Give the command cd, give the space, paste the copied path, and now click on enter. Here, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So this is the localhost and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now sign up and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in and give your username and the password. Click on login. We have logged in successfully and we are redirected to prediction page of the project. So we are doing prediction for all the three data sets individually. So first let's do prediction for SIMARGL data set. So click on that. So these are the inputs need to be given for predicting the intrusions for the data set, for the SIM data set. Let's understand what are these parameters. So first we have is the flow duration, microseconds. So this represents the duration of the network flow in microseconds. A flow is a sequence of packets between two endpoints over a period of time, and the duration is how long the flow lasts. The next one we have is flow duration milliseconds. So similar to the previous one, but measured in milliseconds. It indicates the duration of the network flow, but in the larger time, milliseconds instead of microseconds. Then comes in bytes. So this refers to the total number of bytes received by the destination during the flow. It gives an idea of the amount of data coming into the system or device. Then we have L4 destination port. It is a layer 4 destination port number. It is used in transport layer, that is TCP or UDP, to identify the destination service or application. For example, port 80 is typically used for HTTP traffic. Then we have L4 SRC port. It is the layer 4, that is L4 source port number, like the destination port. This field identifies the source, service, or application from which the idea originates. Then we have out bytes. This refers to the total number of bytes sent from the source during the flow. It tells us how much data is being transmitted out of the system or a service. Then we have protocol. This indicates the transport protocol used for communication, that is TCP, UDP, ICMP. It helps to identify the type of traffic in the flow and how the data is being transferred. Coming to TCP flags. This field contains flags that indicate the status or control information about the TCP connection, such as SYN, ACK, FIN, RST, etc. These flags helps to manage the connection and data transmission in TCP. Then we have TCP win max in. So this refers to the maximum size of the TCP window on the receiving side during the flow. It determines how much data can be sent before receiving an acknowledgement from the receiver. Then comes TCP win min. So this is the minimum size of TCP window on the receiving side during the flow. It helps in controlling the flow of the data, ensures that the receiver doesn't become overwhelmed by too much data in once. Then we have TCP win MSS in. So this is the maximum segment size, that is MSS for TCP connections, indicating the largest amount of data that can be sent in a single packet. It plays a role in optimizing the transfer of the data and ensuring efficient communication. So this is about the parameters of SMI ARGL dataset. Let's enter these values. So for that, we have to open the sample file. So this is the sample file for that dataset. Here we have two class labels where there is attack and no attack. So let's apply filter to class 0 and let's enter the cases. So the flow duration. So the flow duration that we have is in microseconds 34877 and milliseconds is 34 milliseconds, and in bytes value is 111 and 53 is the LDST port, and source port is 42719, and out bytes are 220, protocol is 17, TCP flags is 0, TCP flags are 0, win max in is also 0, and then next we have win min is also 0 and MSS in is also 0. Now click on predict. So this given information, it will be pre-processed at the backend. Then it will be fed to the train model, and then we will be getting the prediction. So here we got the prediction that normal flow. That means there is no attack detected in the given case, no attack detected in the given data. Now let's check with the class 1 for the same data set. So here we have only two classes. That is why we are applying filter to only the two classes. So here the flow duration of microseconds is 859, milliseconds is 0, in bytes are 44, and destination port is 12579, source port is 49726, out bytes are 40, protocol is 6, 22 is TCP flags, and win max in is 1024, min in is 1024, MSS in is 1460. Now click on predict. So here we got the prediction that there is an attack detected. SYN scan aggressive. That means there is attack detected. So here you can observe that attack is detected. So this is for the data set 1. Here we have only two classes for the SIMARGL dataset. Now let's check with the NSL-KDD. So click on NSL-KDD. Here we have parameters that are need to be entered. Let's understand what are these. The first one we have is service. This refers to the specific network service being used in the connection, such as HTTP, FTP, SSH, etc. It identifies the application layer service that is handling the communication. Then we have flag. This flag represents the status of the connection, indicating whether it is normal or special connection. It includes SF, REJ, etc. Then we have SRC bytes. This represents the total number of bytes sent from the source in particular flow. It indicates the amount of data that is being transferred from initiating system to the destination. Coming to DST bytes, so this represents the total number of bytes received by the destination in a flow. It shows how much data the destination system receives from the source. Then we have logged in. So this is a binary value indicating whether the user is logged into the system or not. Then we have count. So this refers to the total number of connections made from a particular source during a certain time window. It is used to identify possible patterns like multiple connections from a single resource. Then we have same SRV rate. So this represents the proportion of connections that are made to the same service, that is HTTP FTP. As the total number of connections higher the value might indicate that the system is communicating with a single service. Then we have destination SRV rate. So that is different SRV rate. Here, this represents the proportion of connections made to the different services, that is HTTP, FTP. Out of the total number of connections, it can indicate diversity in services being accessed. Then we have destination host SRV count. So this shows the number of connections to the destination host that are accessing the same service. It helps in identifying if a service is being accessed repeatedly from the same host. Then the last parameter is the destination host different SRV rate. So this refers to the rate at which different services are being accessed at the destination host. A higher value might indicate a diverse set of services being accessed, which could be an indicator of unusual suspicious activity. So this is about the parameters. Now let us enter them. For that, open the sample file of NSL dataset. So, so these are the different test cases that we have. Let us apply filter to the target column. Here we have total 5 classes. So let's apply filter to the class 1, that is class 0. So we are supposed to enter all these values where services 43, flag value is 1, serves bytes are 0, destination bytes are 0, logged in value is also 0, and count is 139. Same SRV is 0.12, different SRV is 0.06. Destination host service count is 15, and the next value we have is 0.07, that is different SRV rate. Now click on predict. So here we got the prediction that attack is detected and that attack type is DOS attack. So here there is an attack and that attack type is DOS attack. Let's check with the class 1. So these are the inputs need to be given. We can select any of the case. So let's try predicting this case where service is 43, 4 is the flag value, SRC bytes are 1, destination bytes are 0, logged in value is also 0, 2 is the count, 1 is the same SRV rate, 0 is a different SRV rate, the next one is 2, and the next one is 0.5. Now click on predict. So here we got the prediction that there is no attack. So here class 1 refers to there is no attack and it is normal. Now let's check with the class 2 for the same data set. So now let's try predicting this first case only. So service is 17, flag is 9, source bytes are 1225, destination bytes are 2449, logged in value is 1, same SRV is, sorry, count is 1, and same SRV is also 1, different SRV is 0, and the next one is 91, and 0.02 is the next value. Now click on predict. So here we got the prediction that class 2 refers to type probe. So there is an attack and that attack type is probe attack. So here probe attack has been detected. Now let's check with the class 3. So let's try with this case only for the same data set. So here the service value is 17, flag is 9, 230 are the bytes, source bytes and destination bytes are 644, logged in value is 1, count is 1, same SRV is 1 and different SRV is 0. Destination host SRV is 1 and 0.75 is the different SRV rate. Now click on predict. So here we got the prediction that attack is detected and that attack is R2L attack. So here R2L attack has been detected where class C refers to R2L attack. So now let's try with the last case of the NSL KDD dataset. Let's try with this case. Here service is 21, flag is 9, SRC bytes are 241, destination bytes are 2698, logged in value is 1, 5 is count, 1 is same SRV and 0 is different SRV, 241 is the destination host SRV and 0.01 is the different SRV rate. So click on predict. So here we got the prediction that U to R has been detected. So here class 4 refers to U to R. So U to R has been detected. So this is how you need to do prediction for the NSL KDD. Now let's check with the CIC IDS 2017. So click on CIC IDS 2017. So these are the inputs need to be given for this data set, that is CIC IDS. So first one we have is the flow duration. It is the total time duration in micro or milliseconds for which network flow is lasted. Then we have forward packet length. This refers to the total length that is in the bytes of all forward packets in a particular flow. And the next one we have is backward packet length total. So this represents the total length of all backward packets in a particular flow. It helps to indicate the amount of data sent back from the destination to the source. Then we have forward packets length max. So this is the average size of the packet sent in the forward direction during flow. Then we have forward packet length mean. So this is the average size of packets sent in the forward direction during the flow. Then we have flow IAT max. It is the inter-arrival time max. So the maximum time gap between the two consecutive packets in the flow. Then we have flow IAT mean. So this is the average time between consecutive forward packets. Then we have forward IAT max. So this is the maximum time between consecutive forward packets. And then next we have that is forward header length. So here this is the total length in bytes of the header of all forward packets in the flow. It gives insights into the overhead added by the header duration communication. Then we have backward header length. It is the total length of the header of all the backward packets in the flow. Similar to forward header length, this shows the overhead in the reverse communication. Then we have backward packets. So it is the rate, that is packets per second, at which packets are sent from the destination to the source. Then we have packet length max. So this is the length of largest packet in the entire flow. Then we have packet length mean. So this is the average of all packets in the flow. This provides the overall view of the packet sizes throughout the communication. Then we have packet length STD. So it is the standard deviation of the packet lengths in the flow. Then we have packet length variation. So it is the standard deviation of the packet lengths in the flow. Then we have average packet size. So here it is the average size of packets in the flow. This is a metric useful for understanding the typical data size being transmitted. Then we have average forward segment size. So this is the average size in the segment of the segments in the forward direction. Then we have subflow bytes. So these are the total number of bytes in the forward direction in a subflow. The last we have is initial BWD bytes. So these are the number of bytes in the initial backward window. That is the backward window refers to the buffer size of received data in the destination. So this is all about the parameters. Now let's enter the values. So for that, open the sample file of this data set, that is CIC. Here we have total 19 features that are to be given and total 7 class labels. So 7 different types of attacks that we will be predicting now. So let's apply filter to the class 0, click on OK, and let's enter the values. So let's enter the first case. So let's enter this case where the flow duration is 23024 and the next four values are 0 and the next value is 2304024, that is IIT max, and the next two values are 0, that is forward IIT mean and max are 0, and forward header length is 32 and the backward header length is also 32. Now let's enter backward packets. So copy it, paste it, and packet length max, next all values are 0. So we have zeros up to initial bytes. So give the zeros up to initial bytes and the last value is 939. So now click on predict. Here we got the prediction that no attack is detected. So for the class 0, it means that it is benign case. So here we got the prediction that it is benign. So that is no attack detected. Now let's check with the class 1. So apply filter to the class 1. So let's enter the first case for this class also. We are supposed to click on CICIDS 2017. So your flow duration is 227 and forward packet length is 14. 0 is the backward packet length. 14 is the forward packet length max. 7 is the forward packet length mean and ID max is 139. 227 is min and max. 64 is header length. Backward header length is 20. And here we have backward packets that are 400, that is 4405. Paste it. And then we have 14 as the packet length max, 7 is mean, standard deviation is 8.08, variance is 65.3, average packet is 9.3, average forward segment size is 7, and the next one is 14 and 0. Now click on predict. So here we got the prediction that attack is detected, and that is bot attack. So your bot attack has been detected. So your class 1 refers to the bot attack. Now let's check with the class 2. Click on OK. So let's enter all the values. So let's try with this case. So here flow duration is 57 and the next four values are 0. So let's give 0 to the next four values, and the 57 is the next value, that is forward IT max, and the next two values are also 0, and the next two values are 32 and 32, and rest we have is backward packet, that is 17543.86, and the next values we have up to initial backward bytes are 0. So let's give zeros. And the initial bytes are 1176. Now click on predict. So here we got the attack detected, that is brute force attack has been detected. So here you can observe that brute force attack is detected. So here class 2 refers to brute force. Now let's try with class 3. So let's try giving this case. So let's enter the values. I have entered all the details. So here you can observe that I have entered all the parameters. Now let's click on predict. So here we got the prediction that attack is detected, and that attack is DDoS attack. So here DDoS attack has been detected. Now let's check with the class 4. So apply class up filter to the class 4. So here are the parameters that we're supposed to give. So let's enter all these values. So I have entered all the values for the class 4 also. Now let's click on predict. So click on predict. Here we got the prediction that DOS attack has been detected. So here DOS attack is detected. Now let's try with the class 5. So here are different values. Let's try giving input. So let's try with this case. So click on CICIDs 2017, where the first value is 6, 2 is the forward packet length, and 6 is the backward packet length. Then 2 is the forward packet length max, and then we have 2 as length mean. Then we have 6, 0, and 0, 24, 20, and the next value. So copy this backward packet length, and the next one backward packet length max is 6, and the next one is backward packet length mean. It is a packet length mean, packet length standard deviation, variance, and here the next values are 5, 2, 2, 0. Now click on predict. So here we got the prediction that port scan attack has been detected. So here there is a port scan attack. Now let's try with the last class. So that is class 6. Click on OK. So let's give this case. Click on CICIDs 2017, and here the flow duration is 73. The next four values are 0, and the next value, that is flow IET max, is also 73. The next two values are 0, and 32 is the next value, that is forward length header and backward length header, both are 32. And then we have backward packet length, that is 13698.63, and all the rest values are 0 up to initial bytes. So let's enter the zeros up to initial bytes, and the last value is 236. Now click on predict. So here we got the prediction that attack is detected, and that attack type is web attack. So here web attack has been detected. So in this way, just by giving inputs to the application will be detecting whether there is attack or not. If there is attack, it will detect which type of attack it is according to the data set. Now let's check with the graphs. Click on graph. So here the first graph which we have is a sample outcome of SIMRGL graph. So this is here on x-axis we have target class and on y-axis we have count. So here this is the normal flow and this is the attack, that is SY and scan aggressive. So this refers to the attack. And this is the confusion matrix. So this is the accuracy comparison graph. Here on x-axis we have accuracy score and on y-axis all the algorithms that are trained on each data set to give the intrusion detection. So here these are the models trained on SIM SIMA RGL dataset. So here we have precision score, here we have recall, this is the FN score. And this is the sample outcome graph of NSL KDD, where on x-axis we have attack count, on y-axis we have count. So these are the different attacks and their counts. This is the correlation matrix, accuracy, precision, recall, and FN score. And here we have for the sample outcome of CIC-IDS 2017. Here on x-axis we have target class and on y-axis we have count. So these are different types of attacks and their counts. This is the correlation matrix, accuracy, precision, recall, and FN score. Now click on sign out. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.